I personally feel like that this was the hardest question on the paper, and I would be intrigued as to other solution methods to the one that I'm ultimately going to talk through because it is the one in the answers. Now, I think a good starting point for this question is just to try out a value of m and n and see what happens. So when I did it, I just went with, I don't know, 4 over 10, just to get a feel for it. So that's going to cancel by definition. But then 5 over 11 straight away fails. 6 over 12, that's good. 7 over 13, no. 8 over 14, yes. And 9 over 15, yes. Okay, so 2 didn't work, but by choosing M and N to be even, I guaranteed that these ones would simplify. So I think that is what I well, that is a good kind of way forward, and that is what I used as my basis. So um, what I did then, this is actually a failed attempt, I gotta say, and I'm intrigued as to whether, anyone watching this video will be like, well, yeah, you just need to do this, this, and this to my method. So in my method, I tried to make it so M and N, I built it up so they were both multiples of a number, and then I tried sort of adding one and or adding three or adding five and seeing if it worked. So this is what I did. I sought m plus 1 and n plus 1 to be multiples of 3. And then m plus 3 and n plus 3 be multiples of 5. Like they're going to automatically be, well, not automatically, but if this one's a multiple of 3, then it makes sense of adding 2 that this one's going to be a multiple of 5. Um, so I tried, by the way, I actually forgot about the m plus 5 when I did it, which is partly why this is a failed method. So I tried to let m and n end in a 2, because that will mean when I do plus 3, I'll necessarily get a multiple of 5. So if I can find an m plus 1 that's then going to end in a 3 and be divisible by 3, then I'm basically there. So I just sort of then plot m equals 32 and n equals 63 out of, well, not out of thin air, but I just thought, sorry, not 63, 62. Um, so I guess I haven't made them multiples of one another, but I just thought, yeah, this will work for the three that I've already ticked, and then I'm going to get 33 over 63. So that would then mean that this one now works because three goes into both, and then 35 over 65. That one's also going to work. What I didn't really think about in enough detail is when I add on 5, I'm going to get 37 over 67, and that fails. So it was a nice try, I personally think. Managed to get very quickly 5 of them satisfied, but we need all 6 satisfied. So I think what I tried then is like I sort of built on it, but it didn't really get me anywhere. So I'm now going to talk about like well, not a much better necessarily, but a successful way of dealing with this problem. Okay, here goes. So when I did it, I didn't really think about how M and N might link together. And if you do, then it can work out really nicely. So we're going to make N be bigger than M. I mean, it doesn't say that, to be fair, but normally with a fraction, it's not top heavy. You could actually, it doesn't really matter, but I'm going to let N equal M plus some amount. And then we're going to get M over M plus K, M plus 1 over M plus K plus 1, and so on up to 5. I think I will write them all down. Okay. So for these to simplify, it actually must be that k is a multiple of m, because otherwise it won't simplify if you just have m over m plus 1, for example. And we also need k to be a multiple of m plus 1, and m plus 2, and m plus 3, and m plus 4, and m plus 5. So now, and I hope this makes sense, like this is a bit of a jump in in like what is going on here, but I've introduced n as like related to m. I've written them all down, and then I've argued that k must be a multiple of m for this to simplify. Or is it for it to simplify, or like it will guarantee that it simplifies, I suppose. And the same over here. So I'm actually going to pick a starting m, and let's go with the simplest thing. Not 1, actually, because it's not going to simplify if you get a 1, but let m equal 2. Then k will equal the lowest common multiple. Actually, it doesn't have to equal the lowest common multiple, but I'm going to choose for it to equal the lowest common multiple of 2, 3, 4, 5, 6, and 7. Now, here's the thing. If you're finding the lowest common multiple of something involving 4, you can ignore the 2 because 2 already goes into 4. It's already going to be in the 4 times table. And if something's a multiple of 4 and 3, it'll be a multiple of 6. So actually, we only need to find the lowest common multiple of 3, 4, 5, and 7. Now, these don't share any common factors. So we're going to get 3 times 4 times 5 times 7. And the easiest way to do this is to do 3 times 7, which is 21, and 4 times 5. Okay, rather than doing 12 times 35, just pick the numbers to make life easier. So multiply the middle 2 and the outer 2. So that's going to give 420. And actually, we're there. Like we are guaranteed for these to simplify. So we're going to get 2 over 420. That is going to work. 3 over 400. Oh, sorry, it's m plus k plus 1, isn't it? That's not quite right. M plus k, so it's going to be 422. Right, that's better. 423. That is necessarily divisible by 3 because the digits of 423 add up to 9, so that number is divisible by 3. 4 over 424, yeah, they're both even. 5 over 425, yep, they both end in 5. 6 over 426, they're both even. And 7 over 427. 7 goes into 42, and 7 goes into 7, so we're absolutely fine there as well. So a possible answer, what does it say up here? Find a fraction m over n. M over n equals 2 over 40, 122 satisfies these conditions. Okay, we went from what I think is quite a tough problem to solving it very quickly using this idea of setting n equal to m plus k. I'm just going to do one more example. There's no reason why you have to let m equal 2. It's the simplest thing. But let's take another look. What about if we went with m equals 3? So then k, we could make it as simple as we can. The lowest common multiple of 3, 4, 5, 6, 7, and 8. You might want to, see if you can get ahead of yourself. You might want to try some other ones out. M is maybe 4 or 5. Okay, there's actually going to be an infinite number. It's not like a special, M and N that only works for one particular number. So the lowest common multiple of this, I can ignore the 4 because if it's in the 8 times table, it will also be in the 4 times table. I can ignore the 6 again because if it's a multiple of 3 and 8, it's going to be a multiple of 6. These actually don't share any common factors. Okay, so This time I'm going to do 3 times 7 times 5 times 8. So I'm going to get 21 times 40, which is going to become 840. So then I've got 3 over 843. That will both be divisible by 3. This is quite a nice one actually because I'm making m over n odd. I said right at the start, why not make it even? But there's no real benefit because if this one is odd, then these are all guaranteed to be even. So it was just like a little strategy I had at the start. 4 over 844. Yes, that will be fine. Okay, I'll just write the others out. These clearly work. 847, a little bit less obvious, but yeah, 7 goes into 8, remainder 1, then 7 goes into 14, no remainder, and then 7 goes into 7. And then finally, 8 over 848, that is divisible by 8. So nice way of constructing like as many solutions as you want. Yeah, I think I've learned a lot from this question, and I hope you have as well. Okay, well done.